All right, let's look at the homework 3.7, problem number 7. All right, so let's find X-intercept and Y-intercept first. All right, so to find an X-intercept, we set this guy, so it's a 5 to the 5 over 3 minus 5x to the 2/3. All right, so I'm going to pull out the common factor, so it's going to be x to the 2/3 power. Right, if you pull out x to the 2/3 from x to the 5/3, so 5/3 minus the 2/3 is going to be 1, so it's going to be just x, and then you're going to have minus 5. So we're setting this equal to 0, so you can see that x is equal to either 0 or 5, so 0 and 5, right? So smaller x value is 0, and y value is of course 0, and 5 comma 0, right? Then the y-intercept is y of 0 is obviously 0, so we know that it's at 0 comma 0, right? So let's type it in. So we have origin 0 comma 0 and 5 comma 0. Then y-intercept is 0 comma 0, right? So let's check the answer. All right, it came back and we got the intercepts correctly. Let's find the local max and local min. All right, so take the derivative so that we can find the critical number. So y prime is equal to 5/3 x to the, subtract 1 from the power, so it's going to be 2/3 power. And then negative 5 times 2/3, so it's going to be 10/3, right? Then x to the, subtract 1 from the power, so negative 1/3, right? Then we're going to pull out the common factor here. So I would probably pull 5/3, and also x to the negative 1/3, right? So if you pull out the 5/3 and x to the negative 1/3, it's the same thing as multiply by x to the 1/3. So it's going to be just x here and a minus 2, right? Then so this is going to, we want to set this guy equal to 0. Actually, before we do that, maybe I'll rewrite it. So 5 is on top, and x minus 2 is on top too. So those are the two guys living upstairs. And 3 is going to be on the bottom. That's obvious, right? But here is a negative power, and so x is going to be on the bottom with the power 1/3. So you have a 1/3 power. Right, so if you set this guy equal to 0, you can see that the numerator equal to 0, so x equals 2 is one of the critical number. Right, and there's another critical number because y prime, and if you plug in 0 for x, is undefined, which means that the x equals 0 is a critical number of second type, right? All right, so we have a critical number, and we can just do the number line analysis here. So here you have a number line x, and critical numbers are 0 and 2. All right, then we can just check the sign of y prime. So y prime of, say, negative 1, right? So if you plug in negative 1, so here bottom is negative. Negative 1 minus 2 is negative. Negative divided by negative is actually positive. And if you try y prime of 1, so we have 1 minus 2 is negative. 1, so it's going to be negative, right? Then we have a y prime of, say, 3. 3 minus 2 is positive. Everything is positive, so you have a positive here. So the original function y is actually increasing here, and decreasing here, and increasing here. So we know that you're going to have a local maximum here and local minimum there, right? So local maximum happens at the 0 and local minimum happens at the 2, right? And we know that when x is 0, y is 0, so we have that. When x equals 2, so what's this? Y of 2 is equal to, right, it's a 2 to the 5/3 minus 5 to the 5 times 2 to the 2/3, right? So this is going to be, maybe we should rewrite it. So this is going to be, this is the same thing as 2 times 2 to the 2/3 minus 5 times 2 to the 2/3. So we can probably write it as a negative 3 to the times 2 to the 2/3, right? So it's a negative 3 times 2 to the 2/3, right? So let's type it in. All right, so we have relative maximum is 0, 0, and the relative minimum is 2, negative 3 times, maybe I'll write, let's see, maybe I'll times 2 to the 2/3. All right, so I'm gonna erase the parentheses. We don't need that. All right, so let's check the answer. All right, I came back and looks like we got local max and local min correctly. All right, so let's find points of inflection. All right, so points of inflection, we're gonna have to, let's see, so we have to take a more derivative. So we have y double prime is equal to, all right, so I'm gonna do this one. So it's gonna be put 2/3 in front, so you have 5/3 already. So 10 over 9. X to the negative 1/3, right? And put negative 1/3, it's going to be plus 10 over 9 x to the negative 4/3, right? So I'm going to, let's see, pull out, say, obviously 10 over 9 is a common factor, which is nice here. And I'm going to pull x to the negative 4/3, right? So if you do that, you're going to get, let's see, if you pull out the x to the negative 4/3, it's the same thing as multiply by x to the 4/3 here. So it's going to be just x to the 3/3, right? Then you're going to have plus 1, right? So if you set that equal to 0, so you can see that x equals 0 and x equals negative 1, right? So we're going to look at the do the number line. All right, here is negative 1 and we have 0, right? Then we look at the sign of y double prime, right? Oh, actually, sorry, I messed that up here. This is actually not, this only gives you negative 1 because maybe I should rewrite it this way. Right, this is actually 10 over 9. Then you have x plus 1 and x to the 4/3 power. So if you set it equal to 0, only number you get is x equals negative 1, right? But since the y prime double prime is 0 is undefined, right? Like before, so we're gonna put that number there too, right? All right. So then here, we can try -2, right? So if you put the negative number, right? So the denominator is always positive because here you have a 4th power, even power there. So put negative, so it's going to be negative on top, so this is going to be negative. Right? If you try f double prime, plug in anything between -1 and 0, so it's going to be -1/2. Right? If you put -1/2, it's going to be positive, so you have a positive. And if you try y double prime of, say, bigger than 0, 1, positive, positive, everyone's positive, right? So we know that the original function is going to have a concave downward there, and a concave upward here, and a concave upward. And you can see that the inflection point is going to be at -1. Right, so it's going to be inflection point is at the -1 comma. Right, what's y of -1? Right, if you plug in -1 here, that's -1. If you plug in -1 here, so it's a 2, so it's +1, so it's -5. So it's going to be -6. Right, so inflection point is -1 comma -6. All right, so let's check the answer. All right, I came back and looks like we got the points of inflection here. All right, then when you look for asymptotes, horizontal asymptotes, we do not have horizontal asymptotes, so it does not exist. And a vertical asymptote does not exist because there's no fraction, there's no denominator there, so it does not exist. All right, so let's check the answer. All right, I came back and looks like we got this one correctly. All right, then here, let's look at a picture. All right, so the graph is going to be increasing, decreasing, increasing. So let's check to see if we have. So first one, increasing, decreasing, increasing. Second one is not, so we eliminate the second one. And here, this is not the right increasing, decreasing behavior, so we eliminate the third one. And the fourth one, increasing, decreasing, increasing, right? Then other things we know is that, let's see, so concavity is concave down, concave up, right? Here, if you look at the picture, this is concave down, and then let's see, concave up. All right, so let's see. A concave down here, and it looks like there's a concave down a little bit here. Here it's concave down and concave up here, concave up there. So this is probably the right answer. All right, so let's check the answer. All right, I came back and looks like we have the correct picture as well. All right, that's it. I hope that this was clear.